Greetings and welcome, friends. Mr. Waddy here with my algebuddies. Cameron, of course, here as always. We are going over the homework, which we all did because we are wise individuals preparing for our future. I love it. I love it. So yesterday we were talking about arithmetic sequences. Sequences was just a list of numbers that could even be infinite, and arithmetic sequences were lists in which there was a common difference between each term. All right, so it says write the next three terms in the sequence. So the first term we might call a sub 1. They're telling me is 18. The common difference we call d is -6. And if I'm writing my list, all I'm going to do is subtract 6 repeatedly to find each consecutive term. So 18 minus 6 is 12. 12, let's see, they wanted 3. I guess I'll just write 3 blanks there. 12 minus 6 is 6. 6 minus 6 is 0. So that's the next three terms. Doesn't necessarily mean this sequence stops. It could keep going. It would have gone negative, right? And it could theoretically go forever, all right? But it is arithmetic because it's repeated addition or subtraction. There are other types of sequences that are not arithmetic. Let's see, Ethan, if I want to find the common difference, we could try to figure out, okay, what do I move by like that? We also can find the common difference by subtracting any two side-by-side terms.
Oh, yeah.
Yeah. All right, so the common difference here is 4. I want to point out, could have found that, gentlemen, please. You can leave if you're not going to be a gentleman here. -8 minus -12, right? If I take the former term and subtract the latter, -12 minus -16, or -4 minus -8, I would also get the same thing. That's the same as -8 plus 12, which is 4. Right, so a bunch of ways you could find that. So this one's a little bit weirder, but like I said, let's just find the common difference using subtraction. So the common difference, I don't know, any two I want. Let's pick this one and this one. I'll do 2 minus 3.5. It looks like the common difference is -1.5. Believe so. Right, so that's the common difference. And then once I know something like the common difference, I could put it to work, right, where I can actually find additional terms. All right, so here's one where we're going to find the common difference and then find the next terms by, right, repeatedly adding or subtracting. So does anyone know what the common difference is here? It's subtracting 0.3, right, or -0.3. It's repeatedly adding -0.3, or it's, right, repeatedly subtracting 0.3. So if I want to keep going, I like to sometimes kind of like imagine, right, for the next three terms, fill in these blanks here. 0.4 minus 0.3, what's that going to be? 0.1. 0.1 minus 0.3 is going to be -0.2. And subtract another 0.3, it's becoming more negative. That would be -0.5. All right, so all I'm doing is repeated subtraction or addition for these problems. All right, we also talked about that you could graph your sequence. So if I wanted to do this, I would call, actually, yeah, let's label these. So my first term is -1. My second term is -3. My third term is -5. My fourth term is -7. So if I want to use my x-axis to reference the term number, so right, term 1, term 2, term 3, term 4, etc., I could then plot the value of that term as my y coordinate. So at 1, I have -1 here. Right, notice my scale, I changed it, perhaps different than yours. At 2, I have -3. At 3, I have -5. And at 4, I have -7. Now notice that arithmetic sequences will have points that are in a line. I could find more. Actually, question, what is the common difference here? It's going down by 2. And notice that here, I actually am going down 2 over 1, which I realize might not look like that because the x scale is different than the y scale. But it's down 2 over 1 that I can find any point. So if I want the next point, I could go down 2 over 1, right? Down 2 over 1, etc. Now, maybe it would be helpful, but it would be wrong to draw the line that these points are on. Because, right, I could use that line, sure, it would help me to find, the next points in the sequence. But the problem is everything on the line is not necessarily a point in the sequence, because I can have a second term, but if I ask you what the 2.5 term was, it's not there. These are like counting things. I can't count fraction or decimal terms. They're just counting numbers. So a line is actually incorrect because I can't have a 2.5 term, even though I might be able to predict what it would have been. This is actually not a continuous function, it's discrete. So it's just the series of points is the idea. Let's see. Fractions. All right, so it says, write an equation for the nth term and then find the 10th term. All right. So let's label some of these things. What is the first term that I have? What's the first term? Yeah, 1 over 2, 1/2. So I need the first term. I need the common difference. It looks like it's adding by 1/2, right? I also need to know n, the number of the term I'm looking for, and I'm eventually going to also be looking for a sub n. Now, all of these are related to a formula that we had, where if I start at my first term, I can repeatedly add 1 less than the term I'm looking for, multiplied by the common difference, okay? So the number of times I add 1/2 will be 1 less than the term I'm looking for, is the idea. So having this little formula mesmerized will be helpful for tomorrow. In our case, they want an equation for the nth term, so we'll give an equation first. So I would have a sub n is equal to, the first term is 1/2, plus n minus 1 times d. So here's just like a general equation. I could also simplify it. All right, if I distribute the d here, if you wanted to write 1/2 plus, oh, wait a minute, I know d. Sorry. 1/2. Right, so here is an equation that represents that. I also could, like I said, distribute here. So that'd be the same as 1/2 plus 1/2 n minus 1/2. And if I combine these, yeah, put it back, please, Ethan. If I put these, combine those like terms, I would notice that I also could just find the nth term by just taking 1/2 of n, which is interesting, right? Because do you guys agree that those like terms cancel each other out? So here's 2 ways I could have a formula for the nth term. If I want to find the 10th term, what is n equal to? If I'm looking for the 10th term, I would plug in 10, and I would be trying to find a sub 10 is what I'd be looking for. All right. So, gentlemen, let's now get distracted. So if I want to find the 10th term, I could use, right, this formula, 1/2 plus 10 minus 1 times 1/2. Or I could actually use this formula and plug in 10. This formula is surprisingly easier if I modify it as such. Let's see, 1/2 plus 9 times 1/2. That's 1/2 plus 9/2, which is equal to 10/2. And I get the 10th term is equal to 5. Now, the big idea of having a formula for my pattern is it's so much better than repeatedly plus 1/2, 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 right? If I was looking for the 50th term or the 1000th term, a formula would be el más rápido than not. Question, comment? Right, which I know because I actually have a formula in this case. Yeah, just 1,000 divided by 2. So you actually knew the 1000th term was 500, and you knew it super quick because you knew a pattern or a formula. All right, I like this. I like this one a lot. So each small square represents 1 square inch. Devin, you can put your phone away. Determine whether the areas of the figure form an arithmetic sequence. So what is the area of this? 1. So my first term would be like 1. What's the area here? 5. Yep. What's the area here? 9. Okay. So I think this is a pattern. Do you think this is... Well, actually, could someone describe the pattern for me? What's happening? It's adding 4. If I wanted to draw the next picture, what would that look like? What would I do to this? If I wanted to... Right, I would add a box. It looks like it's moving out in these 4 directions. And that would be 4 boxes that get added. And that's why, right, you're saying I would just add 4. And that plus 4 is what I would refer to as our common difference, D. All right, and because there's a common difference here, then I could say that this is an arithmetic sequence. So that's the first answer. It is arithmetic. Right, Pooja? Because there is a common difference. Common difference. Okay. Now, then they ask me to find out what is the 30th if this is a function. Write a function f. Okay. That represents the area, I guess. So if I want to find a function that when I plug in 1, I get 1. When I plug in 2, I get 5. When I plug in 3, I get 9. What would that function look like? Well, let's use this here. So let's see, that'd be my first term plus n minus 1 times d. I'll call this f of n function. And what do I know? What's a1? 1. Common difference we already said was 4. If I want to write a function, I'll leave the n and the a sub n generic. So I could say that a sub n, if you want the nth term, that's just going to equal 1 plus n minus 1 times 4. So here's a function that would work. We could simplify this. Let's distribute. So that would be the same as 1 plus 4n minus 4. What's that simplify to be? What can I combine? What can I combine? Yeah, because I can combine these like terms. So I could call that 4n minus 3 is equal to a sub n. I could also call that f of n. Bunch of different ways I could name that. So here's a function. So if I want the 30th term, the 30th thing in this pattern, I could do that by plugging in 30 for n. All right, so I could say f of 30. I'll write it both ways. This is the same as a of 30. A sub 30 is going to equal 40 times, nope, 4 times 30. There we go. Minus 3. Hundo 20 minus 3. 117 is f of 30. So now I actually know the area of the 30th figure in this pattern. All right, well, thank you so much for watching, mis amigos de Internet. Adios.